resources that I would have had in my classroom, and ensure that I wasn't going to be the only one in the school able to do this. That there's before me, after me, teachers with different ability children from different backgrounds could all engage with the skills, because fundamentally it's been shown that for the future are going to require an element of computational thinking, not necessarily coding, but understanding how computers work and being able to control those computers will require a computational thinking element to the set you'd require as a student going into the world of work. Look at this first image. This is the image that was out to advertise this webinar, and it made me smile, because this is the sort of thing that I think scares many teachers. It scares many children. What on earth does that mean? What's it trying to do? And it perpetuates this idea that coding is something a bit mystical, a bit technical. Many teachers, I think it's to them, it is something you've got to try and get to. But many teachers know they're not interested in trying to get to this image and what image means, or even trying to get to ever thinking about being able to teach it. So I'd like to see things and images like this used for when we're talking about computing. Got two young children, two girls, as a matter of fact, just working on a computer, and you just see in the bottom left the device they're using. Yes, but this could be something that children, they could be writing, it could be working on a web page, and if you didn't notice what that lady is holding in her hand, you would know that she was doing something with computing. Now, this was an activity that I run with these children this week, in fact, yesterday, and these children had never coded before. We introduced them to the idea of coding. They knew an awful lot about computers. They knew what the word USB in the class understood that USB what it stood for. I'll leave you with that thought if you want to type it in the chat window if you know what USB stands for. But this is common vocabulary that children have, but have an understanding about what it means. So it's important that we start to discuss these things and find ways of introducing them in our curriculum. This is a sort of thing coming at with computing in the classroom, is that I want it for all children and for teachers for all abilities. That sent me on a bit of a journey. So when I was at Microsoft, I spent a long time working with teachers who were comfortable with technology, but equally teachers who wanted to introduce some technology into their classroom but didn't know where to start. So that led me to this idea of the percent of teachers who aren't comfortable with this stuff, get them engaged. So I'm going to take you through this slide deck, which has got resources and ideas that I'm hoping that you'll be able to follow up afterwards. And you can please feel free to contact me on Twitter afterwards if you need any more direction. Some of these are my thoughts, and they're my thoughts alone. They might be a little controversial, but if it gets thinking about this important part of the curriculum, then I think I've done my job. First of all, this is how I look at this new computing curriculum. We had a CT in our classrooms, and we were teaching children about spreadsheets and video and Word and how to word process. And then in the UK 2 years ago, there was a whole curriculum change that has started to sort of spread throughout the globe now, of saying that doesn't really prepare these students for the 20th century. Now, there was a lot of rhetoric about we need to create more computer programmers, more coders. I sort of sat back in sort of horror in that, in a way, because there are lots and lots of jobs that require those skills, and there are lots of jobs that are available. But for the computing curriculum, similar to the creative writing that we do in schools, we teach creative writing to generate the next J. Rowling or other famous authors. We teach creative writing in schools to our students because of that activity gets them to practice language, be imaginative with language, develop their creativity, and to develop those skills that are important, not just for creative writing. I mean, we're not trying to create a whole new band of authors. We want them to enjoy the language, and we want them to engage with it. Really, the computing curriculum, I think, develops another aspect of thinking, another aspect of creativity, another aspect of imagination, which involves the world of digital and involves the world of computational thinking. And I'll break it down into these three areas. This is everything we make: spreadsheets, videos, podcasts, anything we design or create with a computer. Actually, we used to call that ICT. And I refer to that as the digital literacy. Then this hearts piece, which is about staying safe and being responsible users of digital technology. It understands things like cyberbullying. It understands things like a child can understand copyright and copying things from the internet. It has an emotional attachment to it because there are legal implications, and with the issues we have in our schools around keeping children safe, there are all those aspects as well, like digital citizenship. And this is the third piece I think has only an element of it. There's a lot more to it, and that's about controlling to a computer. Seymour Puppet, who talks about, children spend a lot of time engaging with the computer. We know that, but we do not give them the skills to be able to talk to that device, to be able to control it, to be able to master it, to be able to make it do what they want it to, how they want to do it. And that's where I think digital thinking comes in. When we're looking at our whole curriculum, not just the computing side, across the board, if we think of these three things as the holistic approach to technology and digital in the classroom, then we can look at activities. So we could set children a task of making a magazine, so making something digitally. They're going to use all their literacy skills. They're going to have to bring ideas around copyright. Can they copy ideas from the web, copy photographs? How are they making sure that they're staying within those laws, if you like? And then how could they actually utilize coding or computational thinking? So it may be that the magazine becomes a web page, or it's distributed in some way through an app. So all of those three things engaged to a context within the curriculum, you start constructing the sorts of activities that you want to do. And then this can lead to thinking, right, this is where I start with that piece that I think that we're all worried about, well, maybe worried about, but are concerned about, or maybe we think we don't have the skills, which is that digital thinking, that computing piece, and often that relates to coding. So then that sets the scene of where I'm approaching the development of coding in the computing curriculum, and that whole curriculum relates to the rest of the subjects and areas we have to teach. First controversial thought. Any of you, and I know you're not going to answer this, but how many of you have been exposed to Scratch and Python? I'm thinking it's these two programming languages that dominate in schools. Teachers have access to them through training. Exam boards are their favourite. They seem to be the coding pieces of choice, language of choice, because of from computer scientists. And let's stop. Let's look at these languages. They're great, but do they really meet a couple of things? One, the needs of the child. This is not about me as a computer scientist and my interest in this area. It's about the child and access to that child. It's, when we look at computer languages, it's almost like we're going to just teaching kids Latin and saying you have to teach Latin because of all these academic ideas around Latin. But that's great, but it's really what the child needs for the core skills that we want to develop and to engage with. So often say, let's relieve the irritation, which is stop scratching and the constriction, which Python. One young man did say to me that Python was like a Python. It was constricting his enjoyment of computing because it was so difficult for him to learn and really to understand what he could do with it. So this led me to really work to some other ideas how we can get this. I think that happens is this worked on the Cribit project that I'm going to talk a little bit later on about. And what just happened when we sent the first 10,000 out and we advertised it a bet and we worked with the BT on this, that the first thing people wanted to do was send it into space or up into with a hot air balloon. They wanted to wrap a case around it. They wanted to send it 100 miles an hour on a car or build a robot with it. And of course, I was asked Bluetooth. Has it got Bluetooth? Now, these are all questions that I sort of term old man syndrome. That's what sort of, and it's, it is men, and it is men of a certain age. I've got a techie interest maybe, and they suddenly want to do this with these devices, and you can. You see a lot of stuff with the Raspberry Pi, and people are doing some amazing things with it. But then kids doing some amazing things with it. I think a lot of working with Raspberry Pi would have been engaged with this sort of activity anyway. But we're thinking along the lines of technical aspects of these devices, of the coding, of this computational thinking. We've got thinking like a 45-year-old man, and we've got to start thinking like a 7-year-old child. I just want to share the video with you, which is the video that we use to advertise the. I hope it's showing up on your screens right now, and I'm just going to play it. Now, I don't know if you were able to see that or hear it, but it's a video that shows a group of children talking about the Cribit. And they're describing what they want to build. They want to build a hologram of their nan. They want to build trampoline and shoes that hover. I believe that if we can get children engaged in their imagination in that way, worried that they might not be able to build those things. What we think about is let's have a go at trying to build those things. They're using their imagination, not thinking that those things may come true or physically be created. The fact they've come up with those ideas, I think, is one of the first steps and the beauty of computational thinking, that the children are opened up to that sort of imagination. Who knows, one of those children in the future might come back to that idea of trampoline in hover shoes, and when he has all the skills, and when they have, and they're in that role of work, they may come up with that one idea that saves someone's life or becomes the next iPhone or the next Google. So it's about sparking those children's imagination, and the work we've done with children with the Cribit is that children start off with these ideas and then they modify them along the way. Worried that what they create doesn't come into their final idea. They're happy to succeed, and that's the value of what they can do with computational thinking. We'll start with trying to develop some of these ideas in the classroom. Well, I'm up you all with Kodu. Now, I don't know if you've seen it or heard about it, but in the UK, when I was at Microsoft, this was one of the main projects that I led on, where we engaged over 1 million children in 3 years in visual programming. It's Windows only, and there are issues with that, I know, and I'll discuss those later on. It's free. It's available in multiple languages, so we downloaded. There are multiple languages that you actually change it through, and that makes it extremely useful in the classroom. It's very simple to learn as a teacher all I need to do as a teacher is create the context in which these activities can take place. And it looks very simple. It can teach all aspects of computing. So whether you're looking at variables, whether you're looking at iterations, algorithms, all of these things can be integrated and developed through Odoo. GameLab.com, as I said, is a free download, and you see it's highly visual. So it's also highly complex in that you can create very complex ideas by it. So don't let this cartoon-like user interface belie the fact that you can create some extremely complex interactions between objects and having to code those objects. Children can make very, very complex games. Really engaging, and the feedback instant. If it doesn't work, you get that feedback quickly. You can go in, you can make a change, and the children get that feedback and that sense of achievement. Highly accessible. So children, using older PCs, it works very well on, and also the language that it involves means that children with dyslexia or reading problems can engage with this because they use the visual clues to help them decide on what the commands mean. Example. So if you look, here's Scratch and here's Odoo. These two bits of code do exactly the same thing. If these from the point of view of a computer science teacher, you may favor Scratch because it breaks it down. You've got lots of variables to tinker with, and lots of sort of names for those variables. Look at it if you're teaching a low ability class or dyslexic students. Which one would have the greater outcome? And for me, and from experience and from doing this myself, it's the Odoo which allows these children to engage very quickly, and for you as a teacher to facilitate that learning and asking them questions like how to slow it down, why I want to use the right stick on my Xbox controller. So Odoo is a great enabler of introducing teachers so that you can learn with them, but equally you can actually support the children's learning, not knowledge about how to do things, but with questions that we want from 21st century learners about how did you do that? Shall we see if this happens? So for me is one of my main sort of valuable tools to deliver what I'm looking for in a computing curriculum. Now, frowned upon by a lot of computer science purists as not proper coding, but I'm interested in that. I'm interested in those children having that experience, build their own game, and what's to do with the Odoo Cup. Okay, and I know we had one of those in Europe as well. Was the children had to design a game, then they had to present on it. They had to build a whole game studio around their game. They had to develop merchandise and marketing materials. So they got a real world problems of an experience associated with that bit of computer coding. So that's sort of something I think has been forgotten in this coding aspect. One of the things we used to do with the old ICT curriculum was build websites. You could build a website in Word and upload it locally. But there's a lot of great tools online at the moment, and this is one I've used a lot with children. They can actually edit code. They've got to learn the code. They can edit code and see impact. And we'll get, if you've been following the news, the fact that Facebook and fake news that fake stories had an impact on the election. There is a plugin that works with Chrome where you can bring up a website like a news website at New Times, and the website you want to change. So like title. Now you're not actually changing the website, but the children would get their own personalized news page that they'll have created. It's great to have a little bit of fun with, but also they can actually see the code. There's plenty of resources on the website at goggles.mozilla.org, which gives you activities to do and all the resources that you need. And where I think to get kids understanding about editing code, but equally that they can use code to create their own websites. And this might be a way then to moving into using some free online tools around website building. But I think HTML and website building is one aspect that's been slightly forgotten in this whole coding experience. PowerPoint, I've got to talk about PowerPoint. I haven't quite put myself of my Microsoft genes yet, but only comfortable with PowerPoint. Many of the things I've showed already might be, scaring them and might be putting them off. But if they're comfortable with PowerPoint, then PowerPoint to deliver some of the computational thinking ideas. We can, challenge children to make a recipe book, going back to the hands, hearts, and minds. They're making something. They say to them, well, should they copy some famous chef off the internet, like I don't know, an international Gordon Ramsay, for example? Let's copy his recipes. Are they allowed to do that? Should they do it? So you develop that copyright, digital responsibility aspect, and then a teacher might need to learn, instead of having slide after slide after slide, actually make a content page where they can introduce hyperlinks into the recipe book, so you can actually jump to recipes when you want them. Now, we put those together at Microsoft in this document called Switched On Computing, which is free. You can download it. Switched On Computing is a scheme of work that exists here in the UK. It's expensive, but there's a free resource. There are 6 different activities in here, of which the recipe book is one of them. But web pages in Word and also can be hosted locally. You can formulas are in Excel, asking children to build a simple calculator or budget calculator in Excel. All have the fundamental basics of computational thinking. Of I have some information, I can do something with it, and I can do an output. And let's not forget that for teachers, this might be their starting point and way in. So dismiss PowerPoint and the Office materials as something that to start your coding computing journey with. And if you know the phrase, a bit left field, a bit out there, a bit odd, I've discovered, and mainly possibly for older children. We often ask students to make databases, and in days when we've got the internet and the amount of knowledge that exists, to ask a child to make a database in a classroom, they just can't collect enough data to really, I feel, to make it valuable that relates to a real on-world situation. You make Wolfram Alpha. Wolfram Alpha is a search engine that it has a lot of knowledge behind it. It has a lot of mathematical ideas and concepts behind it as well. A lot of machine learning, a lot of artificial intelligence. And interesting things you can do with this. For example, I'll just give a little example there. I can turn a command called geolistplot to cities that I know of, and it will show them on a map for me. That's all I have to type. Now, students can then take that information and do something with that with another command. So they could actually to find out the distance between those 2 places. And they can build up lots and lots of these commands together to form a computer program that solves problems for them. It's what's called a knowledge-based language. I'm finding it fascinating to work with, because it's like having a brain of information, and you learn the language to communicate it with it. Listen to Stephen Wolfram, the creator of this, speak, and he talks about why we still teaching children to deliver calculations. They spend 10 years of their life doing calculations when computers can do that a lot better. What we should be getting children to do is use the computer to do the hard work for them, but do the thinking. So instead of saying, they ask a question to add 2 numbers together, and I watched Stephen actually speak to his phone and roll off a long, complicated equation, and Wolfram language solved it instantly from his phone, and he didn't even type anything in, he just spoke to it. A computer can do that. What we need to be teaching our children is them to think, right, if that's how that equation is solved, what will happen if I change this variable? What will happen if I change that variable, and they use the computer to help them develop answers to the questions that they're thinking of. Want something that's a bit challenging, a bit left field out there, have a look at this Wolfram language. It's certainly something for more able children, it's something for older students. There's a wealth of information on there, and you go to the website now, there are very, very simple starter activities for you to get engaged with. Really interesting idea to start playing around with. I mentioned earlier that one of the things teachers of computer science want to do is robotics, and I came across this little device. It's called Robotic Kit. I've put the link here. Lego dominates the robotics world in schools. Nearly €300 a box for a single Lego robot. This little device is 10 times cheaper. It uses a Scratch-esque like language, very easy to learn, and I've been using this with students where we use other materials to build our robot on top of this. It has flashing LEDs, it has line sensors, so you can program it to follow a line. You can even build switches, so if it bumps into something, it turns around. It's a really interesting, cost-effective way to get your students experimenting with robotics, building on the computing languages that they've already learned. So if you're in robotics and you haven't got money in school, well, not that, I wouldn't say it's just a cheap option, an alternative cheap option. This is a far more cost-effective option, and I believe what you do with the Lego robots is don't really get the full benefit of spending that amount of money on the device. You will do everything you can do with a Lego robot and more, and I think engage children's imaginations a lot more with this sort of device. So I can check that out. Now, some of the questions that were sent to me earlier on were all about offline work. There's a lot of unplugged resources. There's a website called CS Unplugged. I can send that link through later on, which is for the students, which looks at computer science concepts and how to deliver those in activities that are not computer-based. But another great one that I've been involved with, produced by CAS, Computing at Schools here in the UK. You sign up for the website, it's available for free. Unfortunately, the resources are all in English, but once you've got the activities, you can turn those into your own resources. They cover everything from children who are from 6 right the way through to 11, 12. And it's well having a look. So what I'd like to do is just give us a little bit of a break at the moment. And I'm going to run you through one of the activities. Okay, so I'll just give you a moment. If you can find a piece of paper and a pencil, if you could all do that, I'm all interested in you're going to do. I'm going to give you an algorithm. Now, algorithm is just a statement of instructions that children understand that can form the base of a template to develop some computing activity and program a computer. So we have to teach children about algorithms, and there's some interesting ideas around it. So I'm going to give you some instructions at the moment. So I'm going to go to the next slide. So I hope you've all got a piece of paper, and I want you to create the following thing. Little character, and you get that character, and you can only create it from these things. So I want you to draw a triangle, and I will throw eyes, tooth, and an eye. So that. This with very young children, they could be doing this on a whiteboard. They could be doing with cutting out things, or just with colouring pencils. And associated with this, there's listening skills, there's questioning skills. Normally when I do this with teachers and I say draw 3 eyes, they don't get to see the text here, and they mean, you mean the letter I or do you mean an eye? And I keep keep repeating 3 eyes. And one of the things that are fundamental to an algorithm is, and if you get the instructions correct or describe the instructions correctly, the output will be different for each. So hoping that you've all drawn a little characters in those criteria. I did one earlier on, and I'm just going to share mine with you and see if any of yours looks like this. So that was mine. In my PowerPoint presentation, these wings actually willed, so I did a little bit more into it. But in children, you're all going to have lots of different triangles. The feet will be in different places. The wings will be big or small. The antenna, I've drawn an antenna linked to a radio station, but somebody might have drawn an antenna linked to an insect. Right, am I right? Are they right? Well, need to refine our algorithm. So children are learning that algorithms have to have precise language. One of the famous ones is to make a jam sandwich, and I in that all the time, and I think sometimes children get a bit sick of it trying to tell somebody to make a jam sandwich and you do something silly. This is a great way of creating a bit of evidence afterwards. This is my algorithm, this is what I used, and then asking them questions like, how could I improve it? How could I improve that algorithm so that everybody produces the same output? And then you can relate it back to the importance of this in computing. The board is full of activities like this. It has activities to do with decomposition, how to break problems down, abstraction, how to take ideas and break down into their smallest components. And it is really well written, and it's something that I would urge you to download and have a look at if you're to teach. Not alternative because I haven't got good computers, but another element to the computing in your room to teach these aspects and to integrate them to things like speaking and listening, art, as across your curriculum, across your other lessons. So that's barefoot. I did a lot with Minecraft whilst at Microsoft, and again, if you in Minecraft, we're in, but again, now more popular in classrooms. It's not everybody's cup of tea. The children own it. The children are very, very comfortable with it, and it takes a teacher with a lot of confidence to be able to let children put them into the lead on this. Take from our point of view as a teacher, quite dedication to get so not to learn it. You haven't got to learn everything about it, but to actually understand how to implement it in your classroom. As the children own it, so you have experts in your classroom right now. But those of you who are interested in teaching Python or computer science teachers, can be used to teach Python. One of the most fascinating things I've seen it do is in a Minecraft world, you walk into a building and a Raspberry Pi will then take a picture of you outside. Now that's quite sounds quite technical and quite complicated, and it does require a little bit of work. But to code that to make happen is simple and something that children can grasp. And it gives them a platform by which they can start to understand how they can control not just their Minecraft world, but the real world and physical computing devices. The end of this is Microsoft have an education edition, and lots of that coming out, and the way it's structured is I'm still not sure about how I get hold of it from classroom. I'm sure there used to be a Minecraft EDU education edition that has now disappeared. So, but a lot of activities you will see online and being shared by other teachers have been made by that edition. So it can, I would just be wary that what you see as an activity, you go, oh, I'd love to do that. In my classroom, I'm going to learn how to do that. Just be a little bit wary that it's an edition that you can get hold of to use. But Minecraft, it's a simple proposition. It's your children will love you for. And it's one that I think if my way and I was Minister of Education, I would introduce Minecraft in schools, train all the teachers up in it, and I would have them being taught Python through Minecraft, because it engages me to understand how Python works rather than just the text-based that we're printed with in the exams at the moment. Minecraft is it provides a wonderful way of, again, engaging your students in other activities. This is a good friend, Solly. Solly, when I first met him, was 6. He presented me with his business card and told me he was a YouTuber. And you'll be surprised how many of your children, without knowing, have at home have YouTube channels and are sharing some interesting work. And I think that makes it even more important that we teachers engage with them to keep them safe online, making sure that they're using these resources and this digital technology appropriately. I'll play the video, but Solly was 6 when he started his YouTube channel. He's now the grand old age of 7.5, and he really puts out videos about what he's doing with Minecraft, the worlds he's created, the people he's met at different conventions, and inspiration for him. He wants to be a YouTuber. It's not just something that if you see that you ask your children, they will roll off the names of various superstars that are on the web. I've heard of. I'm not sure if you have. You'll be surprised, I'm sure, about the knowledge they have of these people. But when you're back in classrooms, have a look at and introduce your children to Solly the Kid, and just sort of ask them about YouTube and they're sharing on YouTube. And here's I've got that idea more, and again I'll just go. This one is called Roblox, and that you can. The kids seem to be all over it. It's the new Minecraft, but they're not telling us adults about it, just in case we get a hold of it and turn it into something educational. I think they test out what we did with Minecraft, but it's a free online resource that you can sign up for. It downloads the Roblox Studio to your PC, and you can build complex worlds around with objects that can interact with one of them code. I'm still getting to grips with it. It's certainly a steep learning curve, but the beauty of this is I can make a game on my PC and then share it and play it on my Xbox One. And if you go to Solly's video channel on YouTube, there are YouTube videos where he talks about the types of games that he's not making them yet. He's playing them and consuming those games for free online. And it would give your students, especially older students, a great context by which they could actually create Xbox quality games for other students or for a younger audience. So Roblox is well worth checking out, and I would keep an eye on it to see what developments occur as more and more, I think, teachers discover it and see the response from their students. I'm not sure the age of many of you, but 1980s when I was in school, and I was taught BASIC and Fuse BASIC, which is a great intermediate. If you're working with Raspberry Pis and you want to do more with electronics and physical computing, Fuse BASIC is a great way to buy to deliver that. Fuse BASIC itself is free. It runs on a PC if you want to do it that way, and it runs great on Raspberry Pi. It's even integrated with the Microbit. The tip you've got here, you can, but you don't need that. You can buy it separately. You don't need that keyboard. You can just plug it one into your existing Raspberry Pi. The robotic arm is available online, but again, you don't need that. And the beauty of Fuse BASIC is it's self-contained. When I've been trying to learn Python, and I suddenly realized I've got to import a library. Now, how do you know I had to do that? Where do I find that information out about? Here, there is none of that. Here you can just move from something like Scratch, where everything is self-contained, into a more text-based language where you can start writing these commands to deliver the types of outputs that you're looking for to develop a more complex, more computer science, more technical solution. I think that we've been working on to making this accessible to many. This is a great way of leading students into that text-based world of computer program. It's would probably be students who've made that choice, to students who want to engage in this sort of areas of work. You may have other students who have gone off and doing other things and working in other areas, but this now working to a more computer science focused approach to your coding. I'm sure many of you know about QR codes, and I've been using these to generate a sort of Internet of Things type idea, where I've asked students to look at an object, and it'd be a tree, and actually make that tree smart. So the tree either tells you more about itself, or as in one school we had a tree that told you stories. So when they scanned it with their iPad or their smartphone or their other tablet, they got some information that they put on this onto the code, a QR code, and they had actually attached it to their object. I've staff room where all the teachers' cups have mugs have QR codes on them when you scan them, and the kids designed this. When you scan them, it actually tells you who mug it is and how they like their coffee and tea. So it's about kids using digital technology to add information to these objects. Into about €30, and these are great for printing out QR codes, and then they just peel off and stick on. The image you're looking at, something I use with students. It's actually a hoax, and it's apparently a Mayan, American Mayan statue, and a lot of web pages online saying this is proof of aliens visiting, because the statue has a QR code where it should be. So actually scanned it and found that it's actually a link to a technology company in Mexico. Very clever, but again, a nice introducing this to students in your classroom. A Google site there which has lots of QR code resources, and there are hundreds of them for you to choose from with lots of ideas. But then this is a really simple, quick way of getting them to think about objects and coding them and making them smart by actually attaching some digital information to them, and that is accessed through the QR code. A lovely little device. It's about €40. You don't want one for every child, but what it allows students to do, again, is turn everyday objects into devices that, when touched, something will happen on the screen, and that something will happen could be a PowerPoint presentation, or again, because bananas, for example, you can see will emulate certain keys on the keyboard. So if you want to guide like a Pac-Man game type idea, and each one of those bananas represents a different directional arrow. The little at the bottom is actually playing a water piano. So they've connected a making key to those bowls of water, and when she puts her hand in those different bowls of water, they all play a different note. We use this very successfully with children with very complex and severe disabilities and needs, and being able to put or their hand in water or into some squishy, horrible, sludgy concoction that the teachers had made for them, and that action to something on the screen which they see and respond to. It's something really interesting to have in your classroom, especially for younger children. And again, it's starting to take that concrete experience of coding, very young children code robots and digital devices around the floor and being robots themselves, starting to bring it more into a concrete experience, which can then lead on to actually developing computer coding or computing in an environment in a more abstract way. Cribit. I've talked a little bit about this. I worked on this at Microsoft. In the UK, we gave away 1 million of these to children year 7 last year. It was a one-off project, and now the project has carried on. These are freely available now from various websites online and suppliers. But you code it in 7 different languages, one of which is Fuse Basic and Kodu. Both have elements of microbit in them. So you can see that if you were working in Kodu and then you wanted to it and evolve it a little bit more, you could move into the microbit. They're cost effective. They are about 15 years each. So you can buy literally a class set for the same sort of a single Lego kit. It has sensors which allow you to students to create their own science, a test sensor or accelerometer. For me, in school now, this would be my core coding curriculum, because I code in 7 different languages. It doesn't matter which. I can adapt that to in my class. I can get children to see what their code would look like in other languages, not by writing the code out again, but actually clicking a button and it will translate it from a simple visual language into a script-based language and switch it back again. And there is loads and loads of support. I strongly urge you to have a look at microbit.org and look at pix.microbit. You don't even need a microbit to do coding. You have a virtual microbit on the web page, and providing some real interesting ideas to teachers, allowing me to talk to teachers. They are picking this up very, very quickly. You can install any sensors or operating systems. No drivers are needed on your devices. It works across all devices, although it's a bit difficult with the iPad because Apple, in their wisdom, have decided to remove the USB port, but you can do it through Bluetooth. There's even a robot that you can buy, like the Rumble, that you can add in the microbit. So all the time you can add and expand onto this microbit idea for your curriculum. So to move on to just finishing off with some questions that have been left is, computing curriculum from the point of view of coding, that's a small part of it. Think the whole child in hearts, hands and minds. Computing is a cross-curricular skill, and think about how you're going to implement creativity, diversity and accessibility with your computing curriculum. Stick a language like Python, great if you can do it, but what about children who are dyslexic, who just will not be able to make sense of those words and how those sense structures are put together? And then both think about what a child would be engaged by and fascinated by, to be able to go wow after they've done something and created it for themselves. I think you have to be the center of all knowledge on this. Learn with children, and like the website, like with Kodu, for example, again will give you all those resources that you need and activities to support you in that. Questions that were sent, and I'll just sort of run through and answer. Unplugged activities, and saying that they'd get lots of iPads. And for me, if it's an unplugged activity, don't worry about the platform. All the unplugged activities from CS, Unplugged and Barefoot, platform independent. That's the point. They don't need a platform to work on. They get the kids involved in lots of activities that they don't need a computer for. And opinion pad is, I agree with you here. I think a lot of schools have spent a lot of money on iPads, and they're trying to deliver a computing curriculum with them, and there's such a limit in terms of what you can actually do with those devices in terms of the computing curriculum, and especially this coding aspect, is that we're getting, and I think that's the reason why we're getting a lot of Scratch and getting a lot of Python. Such a wealth of resources that I've shared only a small part with you this evening, that I think we're doing children a lot of creative experiences as a result of that. So thinking about how you could do this across the board. It absolutely is. If you think of it, and I mentioned this at the beginning, if you think about learning to code is just like learning a language. You're using it to communicate your ideas to the computer, to take control of those computers and their digital world around them. And I can go back to that piece about creative writing. With creative writing, because of what stimulates in children and how it creates their imagination. I think computing does the same. about, I hope I've sort of explained today, it's not about coding, it's about how computing can deliver 21st century skills than any subject knowledge. And I've sort of explained some of my ideas around Scratch, but continuing to develop skills that we're looking for students and the place of work, but things like real world problem solving, resilience, all of the elements are in, so they are part of delivering a computing curriculum. You can't build something on a computer and without having resilience and really make it meaningful. We have to set a real world problem around it. Potential Scratch, and again, I would say Scratch to deliver physics, mathematics. There are lots and lots of other things out there that will do it. It doesn't have to be Scratch all the time. Have a look around, and as I said, have a look at Wolfram language. You can build simulations and plot data with 2 simple commands in Wolfram. And Cribit can be used to measure speed. And there's a great project online called the Bloodhound Project where they built timing gates with microbits. So I would look around to see what else you can do in that area. So you can do this with Scratch, but it's something that I don't have an expertise in, I'm afraid. To use text-based coding, and again, I like this idea of coding is something that it's something that's around now. My thinking is when they go into the world of work, what will they be coding with? It won't be Python, it won't be Scratch. They'll be coding with some sort of virtual reality or augmented reality type coding language where they'll be moving blocks of code in reality. I'm sure it won't be text-based. But into teaching this in schools, I'd like to see a movement from a sort of concrete physical experience that children get all the way through to an abstract method, which they would get introduced to when they are ready. And once their desire has been ignited, they probably go on to looking at more industry-based languages that are available out there. This is a great cross-curricular opportunity, and for a simple Kodu, you can develop backstories for all the characters. Where's Kodu from? Is it a he? Is it a she? What's its story? You can plan storyboards, and you can even then have children guiding the character through the game, through the story, and you can screen record that using screencast software. I've had one teacher even make a video using screencast software, and there's green screen technology to put children in the world that they created in Kodu. Very smart, but you can see how quickly you can take Kodu on from just writing a story about Kodu right the way through to developing some sort of almost AGI type activity within the classroom. It's a very clever project. This gentleman who we sadly lost this year, this is Professor Seymour Puppet, who developed Logo, and we had Logo in our curriculum for 30 years, yet as we've still not got to grips with coding and computing in our curriculum. But if you get a chance to look at some of his writings online, and if you can get hold of his book called Mindstorms, it's a fascinating read, and it focuses on learning and the way children think, and how computing, and in particular coding, is a way for children to express their thoughts and thinking processes. A quote sticks with me about stop children to think like adults and remember they're great learners, and we as adults should try harder to be more like them. And I think if we followed that advice in terms of thinking about the coding curriculum and what we look for in terms of resources, I think we're a long way to making students have the best opportunities now in terms of their learning and their future job prospects. So that's done, just over the hour. Thank you very much for your time. I hope that was useful. You can get hold of me on Twitter. Get a hold of me through European SchoolNet. Happy to answer any of your questions at a later date. It's been an absolute joy and pleasure sharing this with you. I hope it's been useful, and I hope you all have a very Merry Christmas. Thank you all very much indeed.
Thank you very much, Stuart. This has been very, very interesting. indeed, and I think all the participants have appreciated all the examples that you provided. We have 3 quick questions, if you still have a couple of minutes for us.
Yeah, absolutely. Fire away.
Basically, we have one question saying, if you students are ready, what program can I begin with children age 7?
When you're ready, I would start with anything. I would start with the Cribit, so you could go online now and get them on computer. So if they've got iPads or if they've got PCs, doesn't matter. Go to mycribit.org. There are tutorials on there. There are activities to guide them through. You can download those as a teacher. So I would start with the Cribit at age 7. I would look at Odoo as another way because there's very little reading involved. And with the Cribit, I would start them on the block languages. So there's Microsoft has one called PXT and there's another one called Block Editor. I'll start them with those because visual, there's very little language for them to have to decode and try and understand what they mean. And it's broken down into nice little areas. A great activity and just spend a day with students just using the 6 basic commands that you find in the Cribit, and we've created all sorts of amazing things with it. So I would start with the Cribit, or I would start with code.
That's perfect. Thank you much. And then the other question we received is, I've never used, from Nora, who says she never used the tools of computing curriculum, and she finds that there are many. So what would be the easiest for children aged 10, 11?
Again, to say it's what you're most comfortable with. So out of the set I've given you today, is I would go for Odoo. I would look at that, look at Cribit, and look at the benefit resources as well. And I think if you had those 3 things in your classroom to look at and to work with, they would deliver your computing curriculum on. You wouldn't else to deliver that. And with both all those 3 things, you can build a whole curriculum for your children age 7 the way up to 11. For that, we'll be doing things with children that are involved mainly around play and floor turtles, where they type the commands in and camera of arrows. I think we do that very well. It's move into a more abstract world of coding using the computer and using commands to control things. It's a problem. But I would, again, Odoo, Cribit, Block Editor, or PXT, and Barefoot Computing. Those areas would certainly deliver everything you need to do to start coding.
Excellent. Well, I would like to thank everyone for joining, and thanks again to Stuart for this very, very interesting webinar. Again, we will send an email around with the link to the recording of the webinar once this is up on our website. It might take a couple of days, but you will be informed. It has been very nice to share this with all of you, and I wish you all a very good evening and Merry Christmas. Thank you very much.
Thank you. Bye.
With the webinar.